kind of structure is to do what? What do we need to do first? Draw a diagram. All right, so we're going to go ahead and draw a diagram. What type of shape are we working with? Rectangular box. What about the box do we know? The shape of the box. Something key to it. Well, beside not the numbers. It's an open face, which is important. A big part, guys, of Calculus 2 and higher level math is if you can draw, it's actually somewhat helpful because you really got to visualize what's going on and you're dealing with geometric shapes a lot because you're working in 3 dimensions. So here's what your box is going to look like. Maybe not like that. Okay. It's maybe not the prettiest box in the world, but I know, guys. It's sketch. This is hip drawing. All right. So you have a rectangular. If I would have done the lines, it would have been too nice. All right. So you have a rectangular box. It's open faced. It doesn't have a top, right? Okay. That's always going to be your first step, and we're going to go back and work with this illustration in a second. Okay, step B, or part B, Jasper, what does part B tell us to do?
It says second, name and define the different variables involved.
All right.
So name variables.
We're going to name and define our variables. Now.
They suggested using X, H, and capital X.
All right. I want you to ignore what they suggest. I want you guys to come up with your own. What's the first variable your group came up with? All right, like it. W for width. Luis, what's another one? Perfect. That's 2 of the 5. Amsadi. What's another variable we can use? I like it. S for surface area. Kai, what's another one? V for volume. And Daniel Blanco, what's my last one?
And L for length.
I like it. For length. We have all 5. Beautiful. What was that? Well, we should, but I think we're using different letters. I think they're using X instead of something.
It's because the question's asking you.
Yeah, so I want to make sure they're meaningful to you. All right, so we have 5 variables. Now, here's the whole goal with any problem where you have more than one variable. The only way we can solve is if we go down to 1, right? So we have to figure out a way to relate these variables together and narrow kind of the path down to 1 variable. So part C is the next part, and I will tell you, a lot of you are going to want to skip B because you're like, oh, it's just tedious naming the variables. But part B is really important because it allows us to move into part C, which is this. Construct equations to relate the variables. And that's what we're doing throughout this whole problem. We're trying to create relationships so that we can end up with just 1 variable left. Now before we move on to this, we can actually go back to part B. There was something in the scenario that already relates 2 of these. So I want you guys in your teams to write a new equation, go down to 4. You shouldn't have to use 5. Yes. Well, all right. So who's come up with the way to narrow it down to 4 instead of 2? Jasmine?
We thought of the length of the rectangular base of the box divided by the height, so we can use 2W equals L.
I like it. 2W equals L. So L is also equal to 2W. Now, do we get rid of L? Yeah, L is 2W, so now we only have 4 variables. Okay, so let's go up to our diagram. This is why we draw a picture and label it. We have width, we have length, which is now known as 2W. And what's our third variable? Height. Good. Okay, part C is to construct equations to relate the variables. Now, what letters have we not used yet? Surface area and volume. So we are going to construct an equation for both. We'll start with surface area, and then we'll move on to volume. Now, before we start, I'll kind of give a little refresher on what surface area is. And hopefully you guys remember this. This stuff like this is on the SAT. Surface area is what? The area not of all the sides,
No, it's like of the
all the surfaces, or what do we call a surface? A face. So it's the area of each surface, or each face, added up. How many faces does this binder have?
3.
No. 3. 1,
two
2, 3 faces. What are the shapes of each face?
rectangles.
Rectangles. So how would we find the surface area of this binder?
Lane 10.
Well, just add big picture.
Oh, lane 10.
Area of each face added together, right? How many faces do you have in this box?
5.
5.
Because
You don't have 6, why not?
Because it's open
It's an
top.
open top. If it wasn't an open top, you would have 6. Question. Well, the face that's in the inside is the bottom, right?
No,
But-
it's the wall. He has this
Oh,
face
I
that
see what you're
you-
saying. I see what you're saying.
But doesn't that count from it being on the outside?
Yeah,
already?
so it's still, it's going to double count because it's the same material being used, it's just a front and a back. That's a good question. So it's still front and back, because we were looking at material, it's going to be the same area. Uh-huh.
So, you're adding on to it,
Mhm.
so if we're just saying using, like different,
What's the area of this face? Just of this front one. W times H, how many of them do we have? 2, perfect. Let's move over to the side. What's the area of this guy? 2W, actually let me move it over a little bit. These do I have? Perfect. I'm going to try to divide it up so you can see it. So we have how many faces so far? 4, and then my last one, that base. Well, it's 2W times W. What's that? Not 3W. 2W squared. All right. Simplify this down. 6WH plus 2W squared. Right? What was that? Yeah, you can factor it out, which we're actually not going to need to do here. But if you needed to, we could totally do that. I'm going to change the order of this and put the W squared in the front so it looks a little bit more familiar. All right, that's good news. How many variables are we down to? 2. All right, who's got the equation for volume? Volume's super straightforward. Daniel?
W, H, 2W,
W times H times 2W. 2W squared H. Perfect. All right, and we are down to 2 variables. Good news, but can we solve yet? No. We can go a little bit farther, though. And before we do that, let's go back to what we're trying to figure out. So part D asks us to identify the variable we're trying to solve for. So identify the variable we are attempting to isolate. What variable are we trying to solve for? So go back with your team, talk about what variable we're trying to solve for. What are we trying to do? So we're going to minimize the surface area, minimize S, and to do that, we will also end up finding the height. All right, before I move E, and we're going to use substitution. I'm going to have to do it on the next page because I'm kind of out of room. But you guys keep working. All right, so E is substitution. All right, so we know that our surface area equation is this. 2W squared plus 6WH. And then I also know that my volume equation is 2W squared times H. Luis, the information we hadn't used yet was what? All right, let's go ahead and write that in. Volume is equal to 4,500. 2W squared times H. All right, now I'm going to let you guys vote on this and be smart, because you can do this any way you want, but your life's going to be more difficult if you kind of go the wrong path. I have this equation and this one. You can isolate W or H, either one. Which equation do you want to isolate, and which letter? Or which equation do you want to use to isolate what letter? You want to use the surface area, you want to use the volume? Which one looks easier? Volume looks easier, and what letter looks easier to get along? H. Get H alone. Exactly right. All right, you guys have calculators. You can grab those. And when you open a calculator, go to your y equals, clear out whatever's there. I want to make sure you're working through this process on your own. 4,500 divided by 2, 2,250 over w squared. All right, what do you think we're going to do with this thing? You got it. Plug it into H. Take your expression, plug it into H, and the good news is now we're going to be just working with W. So plug it in and then simplify your new surface area equation. You have a surface area equation with just W in it now. Take that all the way. Alright, you should be here. We can go farther though. We've gotten rid of H. 6 times 2250. Anybody have that number? It should be less than that. Is it that big? 13,500. And then I have a W on top and 2 on the bottom. How many W's are left? 1, and where is it? On the bottom. Alright, now I have a nice surface area equation, and I'm only solving for W. Go to second window, window, not your table, yeah, window, there we go. 0, 100, and then if you do 0, 10,000. For your, why is our x min and y min 0? Not negative. We're not going to have negative area, right? Negative volume. Alright, after you do 110,000, you can graph it. And it does. It looks like the Nike symbol. It's a quadratic with what's called a slant asymptote, which we haven't talked about yet. What value are we looking for? The vertex. How do we find that? Trace, there's a more accurate way to do it. I've taught you once. Calculate. Second trace. What are you going to calculate? Number 3. Go down to minimum. Press enter. And now you have to choose a left bound and a right bound. So move your arrow over to the left of the vertex. Press enter. And then move it over to the right of the vertex. Press enter. And then it's going to ask you to take a guess. You can see on the top how they have the interval up there. Take a guess down here, press enter. And you should get a pretty accurate number, close to 15. Alright, so here's my vertex at the bottom. One of the tricky things about doing this if you're using the calculator is you're changing letters. What did x represent in our equation? W, and what does y represent? Alright, so what's the minimum surface area? There you go. And that should make sense, because this is your y value, this is your lowest y value, right? Your lowest surface area. And then W, and I'll be right with you, let me finish up solving for W. What equation did you guys use for the W? You can use a lot. What was the easiest one? Well, equals what?
Or 2 times 15 equals L. So are we solving for?
If we're solving for height.
Then H equals 4,500 over.
H equals 4,500 over 2W squared. Good. There might have been even a simpler form of this. Over 2 times 15 squared.
Yeah.
And height ended up being
10.
10, I think. 10. And if you know the height is 10, could you figure out the, well, I mean, you already know the width. Could you figure out the length? What's the length? Length is 30. Why is it 30? Yeah, you're doubling 15. Okay?